This video demonstrates field sampling procedures for 3 wetland assessment tools: the stress gradient, the Wet Meadow Vegetation Index of Biological Integrity, and the Floating and Submersed Aquatic Vegetation Index of Biological Integrity. These 3 tools have been developed and standardized by Dr. Suzanne Bailey and her team at the University of Alberta to assess the condition of reclaimed sites in the oil sands mining area. They are designed for use by aquatic biologists who will work on the site. Any one of these tools can also be used to monitor a site's condition over time until it consistently meets certification standards. New reclamation sites can be evaluated so long as the test site meets the standard definition of a marsh and contains standing open water for the majority of the year. This video accompanies the how-to guide for evaluating marsh wetlands as part of oil sands mining reclamation. The stress gradient is a tool that measures the environmental condition of a wetland relative to reference marshes. It evaluates the stress score of a site based on its physical and chemical variables. There are 3 components to determine the stress score: water, sediment, and amplitude. Amplitude is measured using a staff gauge, which provides a standardized measure of water depth relative to a specific point. The staff gauge is installed in open water a few meters away from the edge of the emergent zone. It should be visible from an easily accessible vantage point, since multiple readings will need to be taken throughout the field season. Hammer the staff gauge about 3 feet into the sediment to ensure its stability. It should be deep enough into the sediment that it will not sink or shift during the field season. Make sure that the gauge is level. Record the installation's GPS coordinates. To use staff gauge measures to determine changes in the maximum depth of the water, you also need to record the difference between water depth at the staff gauge location and water depth at the deepest point in the wetland. The deepest point can be determined following the method described in the companion handbook. Take a kayak to the deepest point at the beginning of the field season and measure the water depth.
I found the deepest spot.
Okay.
It's 97 centimeters.
Okay, great, got it.
Staff gauge readings should be taken at a minimum of every 2 weeks from early May to the end of August to ensure an accurate measure of amplitude. The amplitude value is determined by subtracting the lowest water depth recorded throughout the field season from the highest water depth. The 4 remaining stress gradient measurements are taken once during the season. Chemicals in water obviously concentrate as the water evaporates, so it is important to standardize the time for sampling. Since regional rainfall tends to peak in July, it is recommended that water sampling take place in mid-August. Water clarity measurements, conductivity readings, and water samples for lab analysis are collected in a kayak at the deepest point in the wetland. It is important to use a kayak to avoid disturbing the sediment. Water clarity is measured using a Secchi disc. Secchi measurements should be taken on the shaded side of the kayak if possible, and if sunglasses are worn, they should be removed prior to Secchi depth determination. Lower the disc into the water until it is no longer visible. This measurement is the Secchi down depth. Lower the disc again, past the visibility point, and then slowly raise it until the disc becomes visible. This is recorded as the Secchi up depth. An average of the Secchi down and Secchi up depths produces the Secchi depth. Avoid touching the sediment with the disc so that you don't inadvertently stir it up into the water column. Once the Secchi depth is determined, the maximum depth is measured with a meter stick. The Secchi depth is then divided by the total water depth to yield a Secchi proportion. This value reflects the relative clarity of the water. A 1-liter water sample is collected in an acid-washed sample bottle. Remember to label the bottle before taking the sample. The sample will be used for lab analysis of nitrogen, a water metric, and chloride, a contamination metric. Use latex or vinyl gloves to avoid contaminating water samples. Never use nitrile gloves. Care must be taken to avoid contamination by disturbed sediment. Rinse the sample bottle and the bottle lid 3 times in the pond water. Be sure the water column is sampled without disturbing the sediment bottom with the sampler. Then rinse the water sampler by lowering it 3 times into the water column. Submerge the sampler one more time and plug the hole at the top with your finger. Lift it out of the water as you invert it. Release your finger and empty the water sample into the labeled sample bottle. If the water depth is less than 20 centimeters, the water sample should be taken directly into the acid-washed sample bottle. To sample directly into the bottle, the cap is removed and the bottle is lowered into the water, mouth first. Once entirely submerged, the bottle is inverted and allowed to fill. The cap is applied beneath the water surface. Once the water sample has been taken, it should be kept in the cooler on ice and submitted to the lab within 24 hours. Otherwise, field pre-processing steps will be required to preserve the water chemistry. Information about sample pre-processing should be obtained from the laboratory carrying out the analyses before setting out into the field. To measure conductivity, lower the tip of the conductivity meter so that the probe is submerged. Wait for the conductivity meter to stabilize and record the conductivity reading. Sediment samples are taken from the emergent vegetation zone at 3 equidistant points around the wetland. You can expedite sampling procedures by taking sediment cores during wet meadow vegetation sampling. If there is no emergent zone present at the wetland, the sediment core can be collected at the edge of the open water. Sediment cores are taken with a suction corer. The core is pushed about 20 centimeters into the sediment while the plunger is held still at the surface. Pull the core out of the sediment while holding the plunger in place to remove the sediment core. Extrude excess sediment until you have a 10 centimeter core. Any type of corer that can collect a sediment sample of the same volume can be used, but we recommend a suction corer where the plunger seals the tube, creating a suction to retain the sediment in the corer. Deposit the sample in a labeled clean glass container. Do not use plastic storage containers, as hydrocarbons in the plastic may contaminate the sample. Repeat this process at 2 other locations around the wetland. All 3 cores should be stored in the same glass container, as they will later be homogenized into a single composite sample. Sediment and water samples are transported back to the lab on ice for pre-processing, following protocols described in the accompanying handbook. Chemical analysis should be done by a professionally certified lab. The Wet Meadow Vegetation Index of Biological Integrity is a tool that estimates wetland condition based on plants growing in the wet meadow zone. Vegetation is sampled between late July and the end of August along 3 transects perpendicular to the shore that originate from the center of the wetland. The location of these transects should be determined using aerial photography or GIS prior to commencing fieldwork.
Okay, well, what do you have?
So these are the sites that we have in our study area. So,
What is this site right here?
this one?
Yeah.
This tool is only suitable for use in wetlands that possess a wet meadow zone.
So we'll go with this one?
Mm-hmm.
Okay.
Use a random number generator from 1 to 360 to locate an angle from north for the first transect.
So your randomly selected transect is at 64 degrees from north.
Okay.
The subsequent transects are drawn 120 degrees from the original, so that all three transects are an equal distance apart. The aerial photograph can then be used as a map to find the transects once fieldwork commences. If there is no wet meadow at the first transect, the entire three transects can be rotated so that at least the first transect passes through the wet meadow zone. If the remaining transects do not pass through the zone, their associated quadrats are recorded as having no species.
So it looks like
Once in the field, GPS coordinates should be taken at the upland edge and at the emergent edge of the transect.
this way is north, right? Yeah. Okay.
These coordinates will help locate the transect if sampling is repeated in subsequent years.
Can you check
The first measure to make at your transect is the width of the wet meadow zone, from the edge of the emergent to the upland edge of the zone.
Okay, pull it taut, Matt.
At the emergent zone boundary, the wet meadow zone can be identified by a change in species dominance from cattails and rushes to sedges and grasses.
Okay, Matt, pull me back into 15 meters.
The upper boundary of the wet meadow zone is delineated by a change in relative dominance from hydrophytic to terrestrial vegetation. The upper boundary can be confirmed by digging a small soil pit with a trowel to check if the soils are hydric. Vegetation sampling is done in the middle of the wet meadow zone. Sampling is carried out within two 1 square meter quadrats along each of the three transects for a total of 6 quadrats per wetland. Care should be exercised when the zone is narrow to avoid laying quadrats in transitional habitat by placing them about halfway between the emergent edge and the upland edge. The 1 square meter vegetation quadrat is always placed to the right of the transect while facing the open water. Quadrats are placed semi-randomly by throwing them and then arranging their edge to lie parallel to the transect, but in the location where they fall. The first quadrat is placed approximately a meter away from the transect. To ensure accurate quadrat metrics, any vegetation that is rooted outside the quadrat should be carefully removed from it, and any vegetation that is rooted within the quadrat should be moved inside it. The first measure taken at the quadrat is the Rebel pole height. The Rebel height uses a visual obstruction technique as an estimate of vegetation biomass. Denser, taller vegetation will be obscured further up the Rebel pole and yield a larger Rebel height measure than less dense or shorter vegetation. The next step is to identify the various plant species within the quadrat and estimate the percent cover of each species. Percent cover of a species is the percent area of the quadrat that the species occupies based on a bird's eye view. Start by visualizing the amount of the quadrat that is vegetated versus the non-vegetated area. Then determine the proportion of the vegetated area that is covered by each species present. The minimum plant species cover that can be assigned is 0.1%. Any plants that are too small or young to be identified can be lumped together and classified as seedlings or forbs. Plants should be identified using standard taxonomic guides. If any shrubs or trees lie within the quadrat, their percent cover should be estimated at the height of the herbaceous vegetation layer. Vegetation may also be brushed aside to search and find species beneath the dominant herbaceous layer. Plants that cannot be identified should be collected in a field press as voucher specimens for later identification. Once the quadrat has been evaluated, move on to the second sampling. Take 5 large paces to the right of the first quadrat, parallel to the shoreline. Collect the same data at the second quadrat as you did at the first. If you are sampling for both vegetation and stress score metrics at this time, this is a good opportunity to collect one of your 3 sediment cores from the emergent zone. Once sampling is completed at the first transect, walk around the wetland to the next 2 transects and perform the same sampling methods, so that wet meadow zone width is measured and vegetation in 2 quadrats are sampled at all 3 transects. Before leaving the site, remember to check that you have filled out your data sheets.
Otherwise, I think we're good.
We will now cover how to use the wetland assessment tool that we developed to evaluate the quality of shallow open water wetlands based on the submersed aquatic vegetation and the floating vegetation. This index of biological integrity combines 5 metrics to yield a score that represents the condition of a particular wetland. Open water vegetation is sampled in 10 1 square meter quadrats, one from each of 10 randomly oriented transects across the open water. These transects are made in a zigzag fashion, with a quadrat placed at a random point along each transect. Quadrats should be located in water between 25 and 150 centimeters deep. The reason for this depth constraint is that floating and submersed vegetation are not usually able to grow in deeper water as a result of light limitation. In shallower water, you may inadvertently cross into the emergent vegetation zone. For each quadrat, drop an anchor to hold the kayak steady. Deploy the floating quadrat.
So it's 65 centimeters deep in the middle of this quadrat. And if I look at the amount of floating vegetation, because this is a 1 meter by 1 meter square, each 10 centimeters is going to be 1%. So you can sort of picture that this is about 98, 97% floating cover. And this is going to be lemna minor. And so we look to see how many different species of floating vegetation there are. And in this instance, this is all lemna minor. There isn't anything else in here. So you can sort of push that out of the way in order to be able to see what sorts of submersed aquatic vegetation are underneath. And I can already see some submersed aquatic vegetation. Then you take your rake, and you're going to want to rake all around within your 1 meter quadrat and try to catch as much of the vegetation in there as possible. You pull that up and you put it on your tray. So you can start by removing all the bits that aren't aquatic vegetation. So then you're going to want to sort it. And most of this looks to be Utricularia macrorrhiza, but there is Ceratophyllum demersum in here. So you're going to want to separate out the sort of different species into different piles so that you can estimate their relative biovolume.
As with wet meadow zone plants, voucher specimens can be taken for any hard-to-identify species.
So we've essentially got 3 different species of aquatic vegetation here. We've got the lemna minor, which we decided was 97% cover, and then we've got the Utricularia macrorrhiza and Ceratophyllum demersum, by far more Utricularia. So I would say we've got 90% and 10% in terms of relative biovolume.
Once you have completed the fieldwork, the accompanying handbook will help you perform the calculations needed to obtain the final wetland score for each of the 3 tools: the stress gradient, the wet meadow vegetation index of biological integrity, and the submersed and floating vegetation index of biological integrity. These scores can be tracked over time to monitor reclamation progress or any unintended impacts on natural wetlands adjacent to oil sands operations. Using these tools consistently will improve reclamation practices through adaptive management and early intervention, and ultimately will lead to improved wetland reclamation outcomes.